Hi everyone, and welcome to section 9.4, which deals with multiplying square roots. So basically we're going to just use this property here. We have if you have the product of, and we used this earlier, if you take the square root of a product, you can factor it into the product of two square roots. Similarly, if you have the product of two square roots, you can rewrite that as a single square root with the product underneath. So let's say, for instance, here, for A, we have square root of 2 times square root of 6. That becomes square root of 12, right? Square root of 2 times 6. And we could reduce square root of 12 because 12 is 4 times 3. And then we know that square root of 4 is 2, so your answer is 2 root 3. Okay. About this one here, we would multiply the whole number part and then what's inside the radical. So you have 8 square root of 3 times 12, which is 36. But what's square root of 36? That's just 6. So then your answer would be 48. Again, if you have variables, remember that it's to the even exponent. So A, you get square root of 24x to the power 4. But 24 is 4 times 6, right? So that's the square root of 4 times 6 times x to the power 4. These are the perfect squares right here. So, when you take the square root of them, you get 2x to the power 2. And then what's left over is the square root of 6. And this has no perfect squares, so that's it. Okay, for B, we have multiplying across. 20 times 5 is 100. Y squared times y cubed is y to the power 5. But we know that this could be rewritten as square root of 100, y to the power 4, y times y. And then this becomes 10y squared, and then inside the radical is just y. Okay. Let's do a couple more like these. So here, this one would have 30. We multiply this part. Then this part here, we have 6 times 18. 6 times 18, p to the power 4. So we have 108 times p to the power 4. Now, we didn't have to write times, it's just p to the power 4. Now, 108 is 36 times 3, yeah? So 36 is a perfect square. So 30, and then you have here 36 times 3, p to the power 4. This comes out, so then you get 30 times 6p squared, because we took the square root, and then what's left is the 3. And then, so final answer is 180 p squared, square root of 3. Okay, what if you have square root of 2 squared? Well, remember that it cancels out, right? These cancel each other out, because square root of 2 times square root of 2, square root of 4, which is just 2. Okay, and then here, square root of 11 squared, this negative is going to become positive, and you're just going to get 11. So that's what this is. That leads us into this. So basically, when you square a square root, they cancel each other out. It's like the inverse operation. So like, let's say here you have 2 times 16, and then you get square root of 3 squared, but then that just cancels out, so then you get 48. Okay, 3 root 6 squared, that's going to be 9, because, the square goes to both parts. Square root of 6 squared, and then you just get 9 times 6, which is 54. All right. Now, we can also multiply, when we're multiplying a single number times a binomial that has a radical, a square root, we just distribute. So this would be 15 minus 3 root 2. This one here would be 4 root 2 minus square root of 20. But square root of 20 reduces. This is already fine, that you can't reduce that. Square root of 20 is 4 times 5. So 4 root 2 minus, and then, remember, square root of 20 is square root of 4 times 5, which is just 2 root 5. And you can't simplify that any further. So let's continue here. We have 7 square root of 5 plus 2 times square root of 5 squared. So that's going to cancel out. You get 7 root 5 plus 2 times 5 is 10. or 10 plus 7 root 5 if you want to like leave the radical at the end. Okay, so let's do a couple more. Here we have square root of 12 plus square root of 108. So this is going to be square root of 4 times 3 plus square root of 36 times 3. So this is 2 root 3 plus 6 root 3, which is finally 8 square root of 3. Okay, what if you have something like this? You know, so you can use FOIL if that's what you've been using, but if you're using box method, that works also. So let's go ahead and do that. You have here 3 minus square root of, no, 3 minus 2 root 7, and then you have 4 minus 2 root 7, and then multiply and fill in your boxes. So you get 12 here, negative 6 root 7 here, negative 8 root 7 here, and then here you have 2 root 7 squared, positive, right? So that's going to be 4 times 7, which is just 28. So then combining like terms, you're going to get 12 plus 28, and then you're going to have plus, and then the two, combine these two together. So minus 8 root 7 minus 6 root 7. So 12 plus 28, that's going to be 40. And this will be minus 14 root 7. Okay, let's do a couple more like that. So here we go. 3 root 2 minus square root of 5 root 2 plus 4 root 5. So then just multiplying, oops. So 3 root 2 squared, the root 2's will become 2, so that's just, so that's 3 root 2 squared, but then these cancel out, so you just get 6. And then the other one here is going to be 12 square root of 10. Root 2 times negative root 5 become negative square root of 10. And then the last one, 4 times negative root 5, 4 root 5 times negative root 5, that's going to be negative 4 square root of 5 squared. So that will cancel out, and then you'll just get negative 20. So then 6 minus 20, that's going to be negative 14. And then you have 12 root 10 minus root 10, so that's going to be plus 11 root 10. Okay. Let's do, this one here includes variables, but it's not much different, right? Okay, so we have 4 minus square root 2 square root of x, 1 plus 3 square root of x. So then you get, filling in the boxes, this is 4, this is 12 square root of x, this is negative 2 square root of x, and then this is going to be negative 6 times square root of x squared is just x. So then together you get, you know, you can't combine these two, so you have to write 4 minus 6x, and then these two you can, that's going to be negative 2 plus 12, which is positive 10 root x. Okay. All right. One thing that might help us is special product formulas. So if you have a binomial, remember in a few chapters ago, I think, we went over how if you have a binomial square, it looks like this, a perfect square trinomial. And it'd be the first term squared plus 2 times the product plus the last term squared. And then similarly here, except that it's a minus when this is a minus. And then a plus b, a minus b becomes a squared minus b squared. So let's do one. So this one here, this is a and this is b. So this is going to be 2 plus 3 squared. That's going to be 2 squared plus 2 times b square root of 3 plus, and then square root of 3 squared. So that makes it a little easier, right? So you get 4 plus 4 root 3 plus 3. So then you get 7 plus 4 root 3. Okay, so then in this case, it's a minus. So you get 4 squared. And then it's going to be minus 2 times a times b, and then plus the last term squared. So 2 root 5 squared. So that's going to be 16 minus, and then here this is going to be 16 root 5, and then the last term is going to be 4 times 5, right? Because it's 2 squared, and then 5 is square root of 5 squared, cancels out. Okay, so then you get 16 plus 20, this is 20 here, so that's 36, minus 16 root 5, and that's it. Okay, let's see here, we have one more. So then this is first term squared, 1 squared is 1, plus 2 times the product, right? Times 1 times 3 square root of x, plus, and then the last term squared. Okay, so this is 1 plus 6 square root of x plus, and then 9 times x, because the square root of x squared just canceled that out. So that's pretty much it. I mean, you can write it 9x plus 6 square root of x plus 1, I guess. And then this last one is for difference of squares. So remember, a minus b times a plus b is going to be a squared minus b squared. So this would be a, and this is b, and this is a, and this is b. So then your product is just going to be 5 squared minus 2 square root of 3 squared. Well, then that's just going to become 25 minus, and then this 2 root 3 is going to become 4 times 3, right? And for those of you that are like, why? Okay, so just in case, so this is 2 root 3, 2 squared times square root of 3 squared. These will cancel out. This becomes 4, and that becomes 3, like that. And then, which is 12. Okay, so then you have 25 minus 12, which is just 13. Okay, and that's it for this section. Good luck. Happy studying. 2 more sections to go, and you are done. I will see you on the next video.